Hey guys, Jerry here. So, we're done with assembly, and now I'm going to talk about the hardware and usage of the cozy SciClone clinostat. Now, before we start, I'm going to talk about the development of other cozy clinostats. So, as you might have noticed, this is not our first rodeo. In fact, this is our fourth attempt at making efficient and consistent 3D clinostats. The first iteration was designed and fabricated almost 2 years ago. Well, it worked, but consistency and longevity were huge issues back then. The second iteration improved on the first, and imaging and lighting capabilities were added for the first time. However, rotational smoothness at lower RPMs became a huge issue. The third iteration improved massively on the second, and it also included a LCD display and a graphical user interface for user-friendly interactions. However, the unit is still too small to fit anything larger than a 60mm Petri dish. This brings us nicely to the fourth and latest addition to the cozy 3D clinostat family. It's larger and far more versatile than any other designs in the past. Expandability and modularity is the name of the game. Unlike version 3, imaging and lighting modules are not included by default. They of course can be added in the future with the mounting points and the auxiliary connectors on the back. The mounting points on the back uses magnets, so in the future, support for different kind of Petri dishes may be added. There are 6 pins on the auxiliary connector, and they're all passed through to the rotor side of the rack, which means imaging modules, lighting modules, and sensor modules may be supported when the need arises. The pre-installed module natively supports 96-well plates. With the use of a retention device, the 96-well plate can be securely attached onto the clinostat. A 3D printed flexible tip cover protects the plate from being scratched. To engage the locking mechanism, insert the retention system through the cutouts, and then rotate to the left. If you're having trouble rotating the retention mechanism, double check that all 4 corners are through the cutout and the Petri dish sits flushly into the indentation. Once the retention system is in place, simply rotate the screw to add tension to the device. To disengage the locking system, simply reverse the previous steps. Of course, the other orientation works as well. Other types of Petri dishes are not officially supported on the 96-well Petri dish mount, but might still be able to function on the current setup. Future support may be added by using the magnetic mounting points or by switching out the mounting base. Alright, finally, time for some action. Like any electronic device, the first step is always to plug in the power. Flip on the power switch and you should hear 2 beeps. That means the device is up and running. The menu is controlled by a simple rotary encoder, with pressing down as confirmed. There are 5 main menu items. Let's start with frame control. The first step to rotation is always to energize the motor coils. And now the frame motors will rotate at a default speed of 1 RPM. The rotational speed can of course be changed in the menu settings Set RPM. The RPM range of the current clinostat is from 0.3 to 15, with an increment of 0.1. Of course, the device can be overclocked to reach higher or lower RPMs, however, this is the range that we find the rotation to be most consistent. If needed, a different RPM range can be achieved by uploading a different firmware. Notice how the RPM indicator on top changes with the current speed. Rotation can be disabled or enabled by pressing the Energize Coil button. And of course, the reverse direction option reverses the direction of rotation. The last option is called Current Offset. We're going to talk about that in a bit. Back to the main menu. The emergency stop option stops rotation in all axes. And now for core motor control. Everything pretty much works the same way, except this time you're controlling the core. The next main menu item is called Linked Control, which means you're controlling both the core and the frame at the same time. And of course, the main menu Reset restores everything to default and stops rotation. Finally, we're going to talk about Current Offset. In simple terms, current offset changes the maximum allowed current through the coils. At higher RPMs, the motors might need additional current to provide rotation without too much vibration. Although a vibration reduction algorithm has already been implemented, it's still nice to fine-tune your motors to achieve the smoothest operation possible. At last, let's talk about the extension cable. One of the reasons why a detachable control box is designed is because the ClimateSat can be used in all kinds of environments, such as environment-controlled incubators or radiation chambers. From the 8-pin connector jack in the back, an extension cable can be added. Simply connect the male extension cord port with the box and the female extension cord port with the base. And boom, you're now ready to control your ClimateSat remotely. Thank you so much for watching, and if you run into any issues or have problems, feel free to message me.